Ready? Okay. So as we had mentioned, control is very important for ensuring CIA and protect the system from DAD, that is disclosure, destruction, alteration. So the notion now that we have been talking of two types of controls, one is the technical control and the administrative control. One of the important administrative control that should be part of an information security document is the access control, physical access control to the building that houses the data center. So the data center can have electrically operated door locks which has sensors and signals for open doors. They have proximity access control. They could have traps and turnstiles to stop piggybacking. So for every biometry based entry into the system, entry into the building, only one person can enter, not many. They could have well trained guards and receptionists. All these are part of your access control. Now what do you mean by training a receptionist? So there is a particular policy that should be followed when a new person enters the organization. If he is going to be a new employee, there should be certain protocols followed. If he is going to be a guest, if he is going to be a technical visitor, he is going to be a visitor visiting a friend. So there are different classes of people who will come to a company. So how to handle them is what you need to train, and these should all be part of your information security policy. And the most important thing is, if this fails, like what do you mean by failure of an access control? An unauthorized person has entered or an authorized person is denied access. Both of these are wrong, and so one of the important thing is how do we handle such type of a contingency situation. That should also be part of an information security document. And then there are specific issues here. If something untoward happens, something that should not happen has happened, then there should be alarms. Like for example, tamper alarms. Somebody tries to break open the door, or somebody tries to break open a biometry device or any access control device. When there is a power failure, what would happen? And suddenly there are some change in the code so some companies give some blue badge, green badge, yellow badge. So a green badge cannot enter a gym, for example, inside the company. It's only for employees, and a green badge can be a consultant. So tomorrow there is a change that consultants also can enter the gym, for example. Now these code change policies has to be quickly integrated into this access control systems. So these are all the things that we need to keep in mind when we devise a physical access control system. This is for entry into the building or entry into different parts of the physical entry of a human being into different parts of the building. So far we have looked at different administrative control like physical access and the segregation of duties. Next we shall look at little more of technical or logical control. So accessing a building, right, through a security mechanism is a access control which is administrative. Logging into a system is again an access control. You are entering a system, but that is a technical access control. Just to give you a distinction between technical and administrative. Now when we talk of access control, we have already talked of the basic things like identification, authentication and authorization. Now identification and authentication are the most important aspect of access control. So how do you identify a user? By his name or in some account or some unique number or ID, it can be also an employee ID. And then how do you authenticate? There are several ways of authentication. It can be a name or a password, it is a remembered information. It can be some key or a button he possesses, an object that the employee possesses. It can be a personal feature like a voice or a fingerprint. It can also be through a dialogue, what's your pet's name, what's your father's name. It can be a callback, it can be a re-authenticate. So authentication can be done in many ways, one or more of these ways. But one of the basic principles, again we go back to what we discussed when we are discussing integrity, is that when we authenticate this an user, the next thing comes to authorization. That authorization should be for the minimal set that assure completion of a task. I as an user come into a system to do a task. For doing that task I need some minimal set of privileges, and this authorization should give me only that minimal set of privileges. It should not give me more privilege than what I need to get as a user. So we identify and authenticate a user who requests for some resource and privileges. We authorize the user for going and using these resources and privileges. When we authorize these users, one of the most important thing is to go and monitor some threats. The threat monitoring comes, we will be talking about that in subsequent modules in greater details, but the threat monitoring essentially is made possible by having logs and reports. For example, a user logs in with many times with wrong password. There are many attempts to log into the system with different passwords, and these passwords are different from each other, much different. For example, one might be say Kamakoti with, suppose I had made A as capital and my password is Kamakoti. Next time I make M as capital and I try, this is not too different. But suppose I say Kamakoti and next time I say Dilip, then these two passwords are very different. So I need to monitor these type. And where do we get these details? We look at logs, we look at reports. So there is a constant monitoring and auditing of the logs and reports. We can't say auditing, more of monitoring of these logs and reports, which will go and find a threat at the earliest possible time and stop that threat from penetrating. So essentially it is a preventive control rather than allowing the system to, exposing the system to threat and then trying to solve the problem by detecting and correcting. We now prevent the threat from entering, and that is what access control does from a logical perspective, from a technical perspective. We have talked about identification and authentication several times, but I believe that I need to repeat it. I will be repeating it a little more time because they have really formed the basis. Now, what is this entire process? So we can neatly summarize with some beautiful questions. Who you are is the identification. What you know, what you have and what you are can be the authentication. For example, who you are is your username. What you know, password, or what you have, basically a token, or what you are, your biometric or your iris, can make the authentication. So these four questions, who you are, what you know, what you have and what you are, can essentially solve the I&A requirement. I&A means your identification and authentication. Now when it comes to authentication, what you are is very, very important. You have face recognition, you have signature comparison, you can have fingerprints, you can have hand geometry, you could have iris scan, you could have voice prints, and all this form the basis of authentication. Now I can, suppose I go and say I will have all these authentications. So for somebody to log into the system, he needs to have a password, then he needs to have a token, then his face has to be recognized, his signature has to be compared, his fingerprint has to be matched, his hand geometry should match, his iris should match, his voice should be there. So one day he has a bad throat, he can't even enter the system. If suppose I have all these things, then the whole day, half a day, everybody will be trying to log into your system. So I again come back to that point that there is a balance between security and productivity. So if I overdo on the security, then your employee will be spending half a day just to authenticate himself that he is him, and so the system permits him to work on it. So I just want to emphasize this point here, because there are different ways, there are different answers in the modern world about what you are, the biometrics, and so there should be a very clear balance between security and the productivity. So one of this can certainly be taken as an authentication measure. Now, why access control is important? We have already seen many of this, but logical access control here essentially means the logical access control, the technical access control essentially fixes for every person his role and the processes that can permit him to read, or for that role what are all the processes that is accessible to him and what each of these processes can do. So without this access control, it is very difficult without the access control, it would be very difficult for an organization to fix a clear role with clear authorization for a particular person, people. So if I have this access control, if that means I could put a clear role for a person, I could fix a role for a person, and I could give the necessary authorization, that means I can mitigate many of the disclosure attacks. I can also mitigate many of the data integrity attacks. So my information can be confidential, my integrity of the information can be maintained. Of course, access control cannot ensure something like availability, right? It does not help, like say my login and password and the authorization that I have on a system cannot stop some other system from clogging the network and making some service unavailable to me. Your access control will not protect you from viruses. So your access control is more or less internal to you and the system, and it does not stop some external thing which is outside you to come and affect the system and hence create some security issues. So this understanding should be there. So when I am creating a system where I am ensuring the CIA, the C and I can come out of control, but for dealing with A, it is not the access control, but you need some different type of control to make things available, which we will be seeing down the line in great detail. So this is the general I&A procedure. Today, what is that is used in common today? You may have several login accounts on Gmail, on Yahoo, your internet banking, your credit card. So you will have several login, and for professors you may have different journals, you would have login and password. You would have several login password combinations. But do you have anything where you are using anything other than this password? Probably in banks you may have a two-step or 2 or 3 step authentication where they may send you an OTP, you may have 2 different passwords. But everything is password, one time password, transaction password, right, a login password. So everything is password here. So now one of the things that we will also see with some justification, that traditional passwords are insufficiently secure. Now people do have hardware crypto tokens which are more secure than traditional passwords. What is a hardware crypto token? It's one device which will be generating random numbers at say every 15 seconds, and this device would be synced with the similar random number on your server. So when I log in from a remote client onto the server, I type this number, and the same number, if the number matches, then your login is through. So this is what we call as an hardware crypto token. And so since the password is changing dynamically, even if somebody guesses, it will be valid only for 15 seconds, next time he can't log in. So when it comes to such type of authentication option, the conventional options are something you know, password, something you have hardware, something you have biometrics such as retinal scans. You have all these things, but in reality, however, till today the authentication is normally all about passwords. Now passwords are everywhere. You go to workstations, you go to network applications, your email, your many websites like Amazon, eBay, as I mentioned, your university course management system, your campus administration systems, your internet banking, your medical and insurance related things. The HIPAA is actually a medical standard. Everywhere we truly use passwords everywhere. It is ubiquitous. So that means all of us must trust passwords, right? So if you call a meeting of all and ask how many people trust password, do you trust a password? Suppose you say no, then if you say no, you don't trust passwords, that may point to a problem, because you can't use any server. Many things that you have today uses only passwords. So you may not be in a position to use any service that is available, any information technology service, IT services that are available. So the best answer today is, I wish you hadn't asked that question. So how many of us do trust password? Though we don't trust, we don't have a go. We go and use it. If one or more of your passwords are compromised, then what happens? All your confidential materials may be accessed, your critical files may be modified, you may be denied access to your own resources. Somebody can go and change the password and also your secondary email, so there is no way by which you can recover. Your personal or institutional reputation may be damaged. For example, they may send a spam, or they can send a very nasty email to your boss, and miscreants can also take your money or even co-opt your identity. So passwords actually play a very critical security role. So if we are going to rely on them, then they better be trustworthy. Now what we now do is, are passwords really secure? And this is a very important discussion, and we will discuss on the insecurity of passwords in the coming section. Thank you.